Today I would like to introduce Liam Wilkinson, who is talking DarkEngine, conducting research onto a highly orchestrated phishing campaign. Thank you, Liam.
Thank you. Hi, everyone. Just a quick mic check. Can everyone hear me? That's fine. The mic's okay? Yep. Thank you. Awesome. So yeah, thank you for being here. It's an awesome turnout for after lunch. I know the after lunch session can be a little bit rough, but hi to everyone in those other rooms as well if you're around. So welcome to DarkEngine, conducting research into a highly orchestrated phishing campaign. So first of all, a little bit about myself. So as for my name is Liam Wilkinson. I go by nullifysecurity online. This is my first security conference presentation, so I apologize if I'm a little bit nervous, as I haven't presented before. So in my day job, I work as a senior capability developer at DFIR for CyberCX, and I architect, build, and maintain our internal incident response tooling, and also help out investigations as well. I have a keen interest in software engineering and DevSecOps, and I also hold the GCFA, GCSA, and GPCS certifications. Outside work, I am a bassist and a vocalist. So if you are in Melbourne and you're looking for an emo band member, it wasn't a phase, hit me up after this. I can also be found playing arcade rhythm games from time to time as well. Awesome. So just some of the topics we'll be covering today. So first of all, we'll go through what actually is DarkEngine. No, it's not something that someone's going to try and sell you. How did we discover it? A bit about the research process, and then what was the actual objective of the attacker, and then we'll kind of summarize everything at the end. So first up, well, what actually is DarkEngine? So DarkEngine is a campaign utilizing SEO poisoning to harvest the credentials of WP-Engine users with the intent of compromising their hosted WordPress sites to deliver click fix in the form of fake capture pages. And there's a lot of words in there. This is a report that we compiled over 2 months of research and was released by CyberCX in June 2025. I've got a QR code up there. It's not malware, I swear. And it's so scary in security cons. People are like, don't scan anything. But I'll also have this at the end as well if, suddenly if something piques your interest and you want to have a look. I'll have a look at some quick stats about the campaign itself. So we identified that it was active since at least June 2024. And we also identified there were at least 2,353 unique affected websites. So 82 of those belong to Australian and New Zealand organizations. We also identified 28 compromised credentials for WP-Engine, but this is likely to be quite higher considering the number of affected websites. We also identified 24 phishing domains that were masquerading as WP-Engine, and then 32 content delivery domains that were injecting pages with fake capture. So the campaign itself, so I've got a little diagram here from the actual report. So I can kind of split it down into like 3 steps, I suppose. So at a high level, the threat actor sets up the phishing pages masquerading as WP-Engine. These get delivered by SEO, and then the victim's WP-Engine credentials are then stolen by the threat actor. And then they use these credentials to compromise their managed WordPress websites with a malicious plugin. And that plugin provides the threat actor with backdoor access to their website and injects a script to serve fake capture content. And this often leads to delivery of credential stealer malware. So the actual report itself goes into a lot more detail about this, and I'll also cover a lot of that in this presentation. But if it is interesting to you, I do recommend checking out the full report. Awesome. So how did we end up discovering this in the first place? Well, in April 2025, we were approached by a client who was experiencing unusual activity on their website, and that kind of led to the discovery of a malicious plugin and scripts associated with this campaign. So we provided the client with some initial remediation actions and collected some evidence, and then got them back in business while we were investigating. So initially, we kind of looked at the client's WordPress logging. So I showed into WordPress. I didn't explain what WordPress is. So WordPress is sort of a website, like a blog hosting site that a lot of companies use to host their website. So we got things from this like the access logs, the server snapshot, and we could see that the threat actor's activity there, but we weren't really able to identify what the initial access vector is for them. So we spent a lot of time kind of looking at whether they had vulnerable plugins or outdated plugins or any vulnerabilities in their website, and we couldn't really find anything. So while we're investigating this, about a week later, well, it happened again. So the threat actor came back, pretty much the same thing happened again. So we're like, okay, great. Well, now we just kind of go deeper. And that was when we learned that the client was using WP-Engine for their hosting. So WP-Engine is a management platform that allows companies to manage easier management of their WordPress website. So you can manage multiple WordPress websites in a single platform. Gives you a lot of nice auditing and a lot of management functionality. So we looked at that audit logging and some SFTP logging from that, and we identified some unusual activity from one of their third-party users. So this was things like logins from unexpected locations and some kind of out-of-place SFTP activity that would later then conveniently line up with the additional research that we performed. So after discovering that, we approached this third-party provider to see if we could perform forensics on the laptop of that user. And in this case, it turned out to be a MacBook. So we ran some standard collections on this, so primarily focusing on web activity and potential credential compromise, considering that WP Engine is a web application. And that's when we found the initial access vector. So phishing was the initial access vector for this one. So we had a look through the Google Chrome history on that device. And here we saw the user performing a Google search for WP-Engine. And then we saw Google Ad Services deliver them a phishing page. And so we identified this through the inclusion of some Google Ad Service specific query parameters. So there's gAdSource and gClickID, which are both associated with those. We then see them access the phishing pages. So there's two of them there. And then they subsequently enter their credentials, including their two-factor authentication into this website as well. And this is kind of what this is what the actual WP Engine website looks like. So here's a comparison of the two. Kind of no surprise to anyone here. I think that threat actors have gotten really, really good at creating credible phishing and cloning pages. So this one is actually a complete working clone. So all the links work, and they were even able to successfully mimic the authentication flow. It's pretty much almost a seamless clone. I used URL Scan, which is one of my favorite open source tools, shout out URL Scan, to kind of get these comparisons, and a lot of the other ones as well. So we also noted from some of the older sites that the threat actor was able to actually keep up with the changes on the WP Engine website. So as it evolved over time, they would also change their website to affect that. So here are the 26 phishing domains that we identified through the campaign. So you can kind of see here a lot of these are common typo squatting or looking similar to the real website, so replacing like P's with Q's, G's with Q's, those kind of things. And I used URL Scan, a combination of URL Scan, virus total, reverse DNS, and wordless scanning to identify these. So I kind of generated just a big list of misspells for WP Engine, and then tried to DNS resolve all of them, and then had to check through them all. It was a bit of a process. So some about these. The earliest identified domain was in June 2024. We observed an increased activity in December 2024 and April 2025, and that was around the time of this investigation. We noted that many of these domains were also using bulletproof hosting, such as BL Networks and Proton 66, and the phishing pages themselves use multiple techniques for defense evasion. So things like base64 encoding the content so it didn't look like it to search engines, and then Unicode in the page titles as well. The phishing site and the threat actor were actually also able to successfully mimic the authentication and authorization flow used by WP Engine, and they perform kind of like an attacker in the middle technique here to proxy the actual authentication to the real WP Engine. And this is kind of seen in the screenshot at the bottom there, where we see two recorded successful logins around the time that the attacker, the user entered their credentials from web proxies. So let's have a quick chat about the research process after this. So initially we found the phishing pages, and so what can we learn from that now? So first thing we'll talk about here is the website manager. So this is identified through the referrer in WordPress and the access logging, and it was a direct IP address, so it kind of stood out pretty quickly. So the website manager, as was contained in the page title, serves as the management portal for the threat actor to view their compromised websites, interact with their malicious plugin, and then submit compromised WP Engine credentials for processing. So by using open source intelligence, things like Shodan, Census, and FOFA, we then went on to discover 5 total addresses serving this management portal to the internet. And this is kind of what it looks like. So this is what we refer to as version 1 of the portal that they use. So you can see here that it displays all the compromised websites and has the ability to select multiple websites and then inject script content into them. And that button is not shown, but it's at the very bottom, and you'll notice that the scroll bar for this goes quite a way down. The add website button at the top displays a modal for them to enter more SFTP credentials to compromise. The scripts button at the top goes to a notepad style site containing scripts that the threat actor can inject into these sites. And then having a look at the source code of this this website, there's a pretty high indication that AI was used to generate this. So there's lots of comments everywhere, pretty excessive use of emojis as well. And we also noted that a lot of the comments, and you can probably see here, a lot of this is also in Russian as well. So potentially goes to identify the attribution, but attribution's hard, so it could be a false flag. This is what it looks like. So when you select one of those websites and you click on the panel, this is what it looks like when you do that. So there's a fetch and save button, which is used to manually fetch information from that compromised website. And this is primarily used to fetch injected backdoors. The admin button requests a special endpoint that was registered by the plugin that actually logs the threat actor in as an administrator directly. The backdoor button displays the total number of backdoors that have been planted on this site. And then when clicked, accesses one of those backdoors at random. And then they also have the ability to add comments. We didn't see too much use of this. So this one here is what we refer to as version 2 of the portal. So a little bit more cleaner looking, a little bit more fancier. We see 2 buttons at the top of this one. So there's an add WP and add WP plus cookies. And this kind of represents a bit more of a sophistication here. So this now we're seeing them use cookies and grabbing those authentication session tokens as well. So it has a drop down on the right hand side that actually allows them to select a particular compromised credential, and then actually will display all the websites that user owns. So that displays it in the work or the not work panel here. And these panels kind of have a special functionality. So the threat actor is actually able to drag and drop between the two to actually reprocess those sites and check if they're working. And pretty similar to that version 1, we see when you click on the site actions, you've got the admin and the backdoor as well. So great. So now we've got this kind of website that the threat actor is using to manipulate their plugin and their website. So how deep does this really go? So we've got a list of, so on the website, sorry, on the management portal, we've got a list of compromised websites we can look at, potentially a list of compromised accounts the threat actor has access to, and a list of scripts that they can inject into their website. Because this is just a standard website as well, the threat actor conveniently uses REST API with kind of no authentication to query these things. So we were able to just identify some API endpoints of interest to us, which I've got displayed here. So we've got some that displays all the websites they have access to, the accounts, and then the API notes. So internally, the threat actor refers to these scripts as notes. So now we've got some kind of cool things to look at. We need a way to continuously query these. So the easiest solution for us to do that was to spin up a new EC2 instance. I used US East 1 for this to kind of blend in with other AWS traffic from a pretty popular region. And I wrote some Python scripts to periodically scrape these endpoints of interest and then dump those into timestamped files. So you can see an example of that on the slide here. I think this is from the API websites endpoint. And we would do this every couple of hours. So initially, this script actually as well used kind of rotating user agents and proxies to kind of mask the activity. But I ultimately ended up just scrapping this as it wasn't really providing any benefit. That didn't look like it had much sophistication to kind of block it anyway. And those free proxies were pretty flaky at best, to be honest. So this provided us a way to monitor the campaign now for any new compromised websites and any new credentials the threat actor had access to. And then kind of track the campaign over time to see what the threat actor was actually up to. So after a little while of doing this, we're like, okay, great. So we've got all these kind of data points. Well, I decided to get a little bit more creative with my research. So since it's open to the internet, scanning it isn't really a crime, right? It's a gray area. I mean, there's scanners out there all the time just kind of scanning me and scanning everything else. So why can't I just do that? So I'm not really a penetration tester. I don't know too much about this. So I was Googling and I was like, okay, great. Well, I need to scan this web server. That's where Nikto comes in. So if you haven't heard of Nikto before, it is a popular web server scanning tool that performs a number of checks against a web server. So for the research in this particular project, the inbuilt plugins and the kind of word list look pretty good. So I just kind of fire that off and see where we went. So after a few minutes of that scanning, we hit the jackpot on this one. There was an open directory at the /server endpoint. And this is what that looks like. So This is kind of what the index page of that looks like. So there's some really interesting files here. A lot of these are kind of temp files that the threat actor is using to migrate some things around. But there's 5 or so files of real interest here. So we've got database.db, which contains details about compromised websites, including links to their backdoors. And these backdoors as well are encrypted. So it also has their key and their initialization vector there as well. The wp-engine_data.db file contains information about compromised wp-engine credentials, and this includes the victim's email address and their password, as well as the path to their cookie file that they have. And we also noted that many of these compromised credentials actually belong to SEO or marketing companies as well, as they commonly have access to a number of managed websites. And this does indicate kind of a higher level of targeting by this threat actor. So there are 3 other server-side JavaScript files of interest here. So these are served on different ports and are used to different services. So the threat actor uses Express.js to serve these. The server.js is exposed on port 3000 and primarily handles compromised sites and the injection of the malicious plugin. Server 2 is exposed on 3001 and primarily handles the compromised user credentials and their associated sites. And the SFTP handler contains the malicious plugin code and utility functions for uploading the plugin via SFTP. So as you can see here, this open directory kind of provided us a pretty big wealth of information about how the threat actor's operation worked. And this revealed, after going through this file, this revealed significant complexity in their operation. So that included basically complete automation of the compromise, from accessing the victim's WP-Engine account all the way through to injecting the malicious plugin. So we noted that the threat actor made a heavy use of the Puppeteer framework, which is a headless browser automation framework to automate their activities. This included automatically logging into the victim's account on the legitimate WP-Engine website, scraping details about the websites that they managed, and then creating an SFTP user to upload the malicious plugin. They upload this plugin to the WP cron file, which is a legitimate file used for in WordPress for scheduling. And then we see them request that file as well, which actually executes the PHP. And so once this is done, the plugin is activated. So this creates the backdoors and injects a script into the header of every site. Speaking of which, the malicious plugin. So it's gone by multiple names over the course of the campaign, but initially when we found this, and the one for the client we're looking at was called WP Anti-Malware Bot, which is a fun one there. It's they were kind of trying to masquerade as a security plugin, but maybe just didn't know how to spell very well. I mean, they yeah. And I've listed here some of its capabilities. So it registered as an emergency login endpoint that when provided a specific query parameter, automatically logs the threat actor in as the first administrator user it finds. It also dynamically injects a script into the header of every page by hooking into the built-in WordPress template redirect function. And that's fired whenever the page is going to be rendered. And this is what the threat actor was using to deliver those fake captcha pages. They also register a custom admin command endpoint that they can also use to update that injected script as well. So it wasn't just a one-time thing. They could change it on the fly as they needed to. The plugin hides itself from any plugin list, so this makes it significantly more difficult for regular administrators of websites to actually see that it even exists. And then finally, it registers a check plugin endpoint, which returns whether the plugin is active or not. And they make extensive use of this in their management portal to determine whether the website is still compromised. So WordFence, who is a popular WordPress security company, they make probably the most popular WordPress security plugin. They have a really, really great technical write-up on this plugin if you are interested in having a look at that. It's also linked in the report as well. So now we've got information kind of about what the how the threat actor compromises these websites and what they're doing. So what's their objective? What is the end goal here? So at the time of our research, we found that the threat actor's main goal was to inject fake captcha prompts into legitimate websites used by the campaign. So fake captcha, clickfix is also known, has become an incredibly common tactic by threat actors over the past year or so. It's frequently encountered by users, becoming more and more obscure every day. For example, clicking the traffic lights, rearrange the shapes, click this 3D moving thing. Like, users will do anything for these fake captchas. And this particular campaign abuses the trust in legitimate websites that users are inherently trusting when they visit. So instead of going to a random domain or being delivered a domain through ads that a threat actor controls, it's actually served through a potentially a website they would visit on a daily basis. So they're more likely to inherently trust this. And we also find that ClickFix often leads to the execution of credential stealer malware, which is commonly sold to initial access brokers and can lead to further compromise of individuals and organizations. So this is what a fake captcha looks like, if you haven't seen one before. And this is what this will look like specifically for this campaign. So it looks like your standard kind of, hey, click here to confirm you're a robot prompt. So you click that prompt, and then a little box pops up and says, hey, I want you to press Windows R. And what this does is actually opens up a Windows command prompt. And then they're like, hey, I want you to paste in this validation code. And then the user does that. And surprise, surprise, that validation code is actually PowerShell that is executed on the end user's device. So this is just one kind of example of one of these. There's been so many variants of this observed in the wild, and they're actually getting more and more complex every day. So this is actually quite an old tactic now. There's a whole bunch of other ones, like they'll get you to paste it into like the Explorer bar. Like as soon as the defenders find something to figure it out, they'll pivot, as most threat actors do. So speaking of which, how do you kind of defend yourself against this? So awareness is really important. So you really want to educate your users on how to identify potential ClickFix pages and social engineering attacks. Information stealers are a really prevalent initial access vector. And so you want to make sure that you're using unique passwords and 2FA wherever possible. And as I mentioned before, these attacks are constantly evolving, and the tactics are constantly changing. They're becoming more and more difficult to detect. So as defenders pick up on them, the attackers are already 3 steps ahead. There's lots of technical mitigation advice out there and lots of detection advice. It's really difficult to keep up with the evolving threat, but ultimately your defense comes down to a good security posture and user awareness. So I've got some small detections, possible detections here. So you can use the run MRU registry key, which is the run dialog key to look for suspicious PowerShell commands. You can use PowerShell logging as well, and process execution if you're logging that. And some mitigations are limiting that run dialog using application control, and EDR/XDR has gotten, it's pretty okay at kind of picking this stuff up as well. So that's the bulk of it. So we'll kind of go through just some quick summary of what we talked about today. So this particular campaign used SEO poisoning to compromise the WP Engine credentials of SEO or marketing company users, and that enabled the widespread delivery of ClickFix in the form of fake captcha. The research that we performed was able to identify a significant number of potentially affected websites and uncover how the threat actors' operations worked under the hood. And all of this was enabled by open source intelligence and tooling that was available online. ClickFix is still really prevalent. It's really important to educate your users on identifying this and other social engineering attacks. And website owners should be vigilantly looking at their audit logging as well and use scanning tools to identify threats early. So it's a pretty big blind spot these days of people who are running websites, is a lot of them aren't looking at these logs and aren't really scanning to check whether they've got these kind of vulnerabilities or these kind of the malware on there. And as you'll probably learn through the conference today and in general, the threats are only getting more and more complex to detect. They're getting kind of crazy. So stay safe out there, everyone. And that is DarkEngine. Thank you so much for coming. Awesome. So you can find me, probably LinkedIn is the best place to find me. I have some handles online, like nullifysecurity on X or whatever they're calling it these days. I've also got that QR code up there, so if you were interested in the report, it's there. There's no kind of marketing in this one, so you don't have to put your email address or anything, and you can just access that and get straight to the report. And yeah, I don't know how we're going for time. We got like a couple minutes. 3?
We've probably got time for a question or two.
Yeah, if anyone has any questions. Hello.
I have 2 questions, that's all right. First one, real quick. So the website manager, like the management portal, was that completely unorth, exposed to the internet?
Correct. Yes. None at all, not whatsoever.
That's
That's why I didn't give you any information about it as well, because some of them are still online, and any user could just go to it and they could just start wreaking havoc on thousands of websites.
That's crazy. Second question I had was, did you notice that any of the compromised sites were being used to stage the malware for the other sites, like ClickFix, Fake Capture, Delivery?
Not particularly. So we did notice that the actual scripts that they were injecting and the domains they were injecting were hosted elsewhere. So they're still hosted on similar providers, but they actually weren't using the compromised websites themselves to deliver it to other websites. So yeah, it was all basically from a lot of those like Proton 6.6 and like BL networks, kind of like bulletproof stuff. They were spinning those up and they had a whole bunch of registered domains for those.
Cool. Also, another question, sorry.
3!
So did it look like the actor was running like a malware delivery as a service model? Like were they deploying a whole bunch of different malware across all the sites, or was it their own kind of credential sealer they were doing?
Yeah, so in the report we kind of go to talk about some more of the attribution in terms of what campaigns. So there's a couple of different campaigns that were kind of tied to this one that they were delivering malware for, but a lot of them were primarily like that kind of ClickFix, fake capture kind of stuff.
Yeah, cool. Thank you. I'll pass it on to someone else.
Thank you. Yeah.
Thank you. Thank you, everybody.
Thank you.